The quadratic equation whose roots are the x and y intercepts of the line which is passing through 1 comma 1. So 1 comma 1 is in the first quadrant. So let us consider the line is passing through 1 comma 1, and let us assume that it cuts the x-axis at the point a comma 0 and the point 0 comma b. So we can say x-intercept is a and y-intercept is b. So the equation of the line we can write x upon a plus y upon b is equal to 1. And since the line is passing through 1 comma 1, so we can write x upon a plus y upon b is equal to 1 is passes through or passing through 1 comma 1. So which implies that 1 upon a plus 1 upon b is equal to 1, or we can write it as a plus b upon ab is equal to 1, or we can write a plus b is equal to ab. Now if this line makes a triangle with an area a units, so area of this right angle triangle is a units. So let us write area of triangle. So let us say this is a and b, OAB, which is equal to half into mod a into mod b. So which is given area is a. So we can write capital A is equal to AB upon 2. And now we need to write and we need to find the value a plus b. So AB is equal to a plus b. So we can write here mod AB is equal to 2 times of a. And from this relation we got a plus b is equal to AB. So mod of our a plus b is equal to also equals to 2a. So when a and b are the roots of the equation, so the quadratic equation we can write x square minus sum of the roots into coefficient into x plus product of the roots is equal to 0. So we can write x square minus the sum is 2a and the product is again product of the roots is again 2a. So x square minus 2ax plus 2a is equal to 0 is the required equation. So which is our option B. Given that 4a square plus b square plus 2c square plus 4ab minus 6ac minus 3bc is equal to 0, then the family of the lines ax plus by plus c is equal to 0 is concurrent at one or the other of the 2 points. So we need to let us simplify this. So we can add here 2a whole square plus b square, and here 4ab we can add 2 into 2a into 4b, sorry 2a into b, plus again here 2c square, and here we can write 3c common, minus 3c I can take common. So we can write 2a plus b, and again the last term is plus c square. 2c square is equal to 0. So here we can write 2a plus b whole square minus 3c times of 2a plus b, and again plus 2c square is equal to 0. So let us consider 2a plus b is equal to some x. 2a plus b is equal to something like let us take alpha. So which implies alpha square minus 3c alpha plus 2c square is equal to 0. On factorization we can write 2c alpha minus c alpha plus 2c square is equal to 0. So alpha taken common alpha minus 2c minus c taken common alpha minus 2c is equal to 0. alpha minus 2c is equal to 0 and alpha minus c is equal to 0. So alpha is equal to 2c, or we can write alpha is equal to c. And coming back here, what is alpha? Alpha is 2a plus b, so we can write 2a plus b is equal to 2c, or we can write 2a plus b upon 2 is equal to c, or we can say 2a plus b is equal to c. And now, since it is given family of lines is ax plus by plus c is equal to 0, so which can be taken as ax plus by plus c can be taken 2a plus b upon 2 is equal to 0, or we can write ax plus by plus c can be taken 2a plus b is equal to 0, or this can also be written ax plus by plus a plus b upon 2 is equal to 0, or we can take a common, x plus 1 plus b common, y plus 1 by 2 is equal to 0. And since it is representing a family of lines, so definitely the point which all the lines are passing through is x plus 1 is equal to 0 and y plus half is equal to 0. So we can write x is equal to minus 1 and y is equal to negative half. So minus 1 comma minus half is 1 point. So which is in the option A, minus 1 comma minus half. And similarly solving the other part. So we can write a times of x plus 2 plus b times of y plus 1 is equal to 0. So we can write, since it is also representing a family of lines, so x plus 2 must be equals to 0 and y plus 1 is equal to 0. Means all the family, that is for a times of x plus 2 plus b times of y plus 1 represents a family of lines, and all the lines will be passing through the point of intersection of x plus 2 is equal to 0, y plus 1 is equal to 0. That is x is equal to negative 2 and y is equal to negative 1. So we got it before minus 1 and minus half, and now minus 2 and minus 1. So the family of lines concurrent at the point minus 2 comma minus 1 or the point minus 1 comma minus half. So which is option A. So option A is the answer. Family of lines passing through. We need to find the nearest point on the line from the origin. So given line equation 3x plus 4y minus 12 is equal to 0, or we can write 3x upon 12 plus 4y upon 12 minus 12 upon 12 is equal to 0. So we can write x upon 4 plus y upon 3 minus 1 is equal to 0. So we can say that the given line having x-intercept is 4 units and y-intercept is 3 units. So the line is passing through the points 4 comma 0 and 0 comma 3. So and we need to find the nearest point on this line, and the line equation is x upon 4, that is 3x plus 4y minus 12 is equal to 0. And we know the concept from a point x1 comma y1, the perpendicular or the foot of the perpendicular upon the line ax plus by plus c is equal to 0. Say m h comma k is the foot of the perpendicular, and it is given by h minus x1 upon a is equal to k minus y1 upon b is equal to negative of ax1 plus by1 plus c upon a square plus b square. So we can write here h minus, here h comma k is the foot of the perpendicular, and 0 comma 0 is x1 y1. We can write h minus 0 upon 3 is equal to k minus 0 upon 4 is equal to negative of ax1, that is 3 into 0 plus 4 into 0 minus 12 divided by a square plus b square, that is 3 square plus 4 square, which is nothing but 12 upon 9 plus 16, 25. So we can write h upon 3 is equal to 12 by 25 and k upon 4 is equal to 12 by 25. So h is equal to 12 3s are 36 upon 25 and k is equal to 12 4s are 48 upon 25. And hence we can say that the nearest point will be 36 upon 25 comma 48 upon 25. So we can go with an option A. We need to find the distance of the point minus 1 comma 1 from the line 12 times of x plus 6 is equal to 5 times of y minus 2. That is 12x plus 12 6 are 72 is equal to 5y minus 10. So we can add 12x minus 5y plus 72 plus 10 is 82 is equal to 0. So this equation of the line is 12x minus 5y plus 82 is equal to 0, and we need to find the distance of the point from the line. So let us consider this point P, and PM is the perpendicular distance. So we need to find PM is equal to, by using the concept from the point x1 comma y1, the perpendicular distance upon the line ax plus by plus c is equal to 0 is given by ax1 plus by1 plus c mod upon root of a square plus b square. So here we can write PM is equal to ax1. So here we can write 12 into minus 1 minus 12 and again minus 5 into plus 1 plus 82 divided by root of a square plus b square, that is 12 square plus of minus 5 whole square, which is minus 12 minus 5, that is minus 17 plus 82 divided by root of 144 plus 25. So 82 minus 17 is 65. 65 divided by root of 169, that is 13. So this is root of 169, which is 13. So 13 5 times we can cancel. So the perpendicular distance from the point minus 1 comma 1 upon this line is 5 units. So which is option D. We need to find that the family of straight lines given here is concurrent at the point. So let us simplify the family of straight lines. So that is 2a plus 3b of x plus a minus b of y plus 2a minus 4b is equal to 0. So we can write, taken a common, so 2x plus y plus 2, and here taken b common, so we'll get 3x minus 1y minus 4 is equal to 0. And since this is a family of straight lines and all these lines are passing through the point of intersection of two lines, so that is 2x plus y, 2x plus y plus 2 is equal to 0, and another equation 3x minus y plus minus 4 is equal to 0. So we can start here 1 by using cross multiplication, 2 and again 2 and again 1, and the next equation minus 1 minus 4 and again plus 3 and minus 1. So here we can consider first two columns are for x and second two columns for y, and the last two columns for constant 1. So we can write x upon 1 into minus 4 minus 4 and minus of minus plus 2 is equal to y upon 2 into 3 6 6 minus 8 is equal to 1 upon 2 into minus 1 is minus 2 minus 3. So we can write x upon negative 2 is equal to y upon negative 2 is equal to 1 upon negative 5. So we can write x is equal to 2 upon 5 and y is equal to, and here we can say actually it is plus 8. So this is 14. So y is equal to negative 14 upon 5. So the point, and we can say that this family of straight lines passing through the point here, that point is 2 upon 5 comma minus 14 upon 5. So we can say it's a point of concurrency, all the concurrent lines passing through this point. So we can go with an option A. We need to find the reflection of the point 4 comma minus 13 up in the line 5x plus y plus 6 is equal to 0. So we need to find the reflection of this point, say Q. So let us consider QH comma K be the image of this point with respect to the line 5x plus y plus 6 is equal to 0. So let us recall the concept once. If the point P x1 comma y1 and the line equation is given ax plus by plus c is equal to 0, then the image of this point Q, say h comma k, is given by h minus x1 upon a is equal to k minus y1 upon b is equal to minus 2 times of ax1 plus by1 plus c upon a square plus b square. So here we can write h minus 4 upon 5 is equal to k minus of minus 13, that is k plus 13 upon 1 is equal to minus 2 times of 4 into 5 20 and minus 13 into 1, so minus 13 plus 6 upon a square plus b square, that is 25 plus 1. So h minus 4 upon 5 is equal to minus 2 into 20 plus 60, 26 minus 13 is 13 divided by 26. So we can write h minus 4 is equal to negative 5, or h is equal to minus 5 plus 4 is negative 1. And similarly, k plus 13 is equal to, we can write minus 1, or k is equal to minus 1 minus 13, that is k is equal to minus 14. And hence we can say that the reflection of this point is minus 1 comma minus 14, which is option A. Given the equations of the pairs of opposite sides of parallelogram are x square minus 5x plus 6 is equal to 0 and y square minus 6y plus 5 is equal to 0. So we can factorize it. X square minus 3x minus 2x plus 6 is equal to 0, that is x times of x minus 3 minus 2 times of x minus 3 is equal to 0, that is x minus 2 into x minus 3 is equal to 0. So you're getting either x is equal to 2 or x is equal to 3. Similarly, for other sides, y square minus 6y plus 1 plus 5 is equal to 0, we can write y square minus 5y minus y plus 5 is equal to 0, or y times of y minus 5 minus 1 times of y minus 5 is equal to 0. So we can write y minus 5 into y minus 1 is equal to 0. So which implies like y is equal to 1 or y is equal to 5. So we can say clearly that the parallelogram with the parallel sides y is equal to 1 and y is equal to 5, and another one x is equal to 2, x is equal to 2 and x is equal to 3. From here we can say that the point of intersection of these lines can be taken as 2 comma 1, and here it is 3 comma 1, and here it is 3 comma 5, and here it goes 2 comma 5. Say this point is A, this is B, C, and then D, and we need to find the equations of the diagonals, so AC and BD. So we know the line joining 2 points y minus y1 upon y2 minus y1 is equal to x minus x1 upon x2 minus x1. So we can write y minus, so first AC diagonal equation of diagonal AC, we can write y minus y1, that is 1, upon x minus x1, or y2 minus y1. y2 minus y1 we can write 5 minus 1 is equal to x minus x1 divided by x2 minus x1. So which implies like y minus 1 upon 4 is equal to x minus 2 upon 1, or cross multiplication we get 4 times of x minus 2 is equal to 1 times of y minus 1, or we can write 4x minus y, and here it is negative 8 plus 1 is minus 7 is equal to 0. So 4x minus y minus 7 is equal to 0 is one equation. 4x minus y minus 7, so we can see here. And now another one, equation of another diagonal, say BD. So with the points 3 comma 1 and 2 comma 5, so we can write y minus 1 upon x minus, or y2 minus y1, that is 5 minus 1, which is equal to x minus x1 upon x2 minus x1, that is 2 minus 3. So that is y minus 1 upon 4 is equal to x minus 3 upon negative 1, and cross multiplication we can write negative y plus 1 is equal to, here we can write 4x minus 12, so that is 4x plus y minus 12 minus 1, that is minus 13 is equal to 0. So 4x plus y minus 13 is equal to 0, or 4x plus y is equal to 13, and y is equal to 4x minus 7. So here we can write y is equal to 4x minus 7. So we can go with an option C. Given that the line 3x minus 4y plus 7 is equal to 0 is rotated through an angle of pi by 4 in the clockwise direction about the point minus 1 comma 1. So let us check first whether this minus 1 comma 1 satisfying this equation or not. So 3 times of negative 1 minus 4 times of 1 plus 7 is equal to minus 3 minus 4 plus 7, which is 0. So we can say that minus 1 comma 1 satisfies, which is on the line. And now this line is rotated through an angle of pi by 4 in the clockwise direction, in the negative direction. So we can say minus pi by 4. So that the equation of the line in its new position we need to find. So this is the new line, or the new position of a line. Now we can find the slope of the line. Slope of the line 3x minus 4y plus 7 is equal to 0 is minus 3 divided by minus 4, that is 3 upon 4. And we need, let us consider, say m1 is equal to 3 upon 4, and the slope of the new position line is m2, and the angle between them is minus pi by 4. So we can write tan of minus pi by 4 is equal to, we know the formula, tan theta is equal to m2 minus m1 divided by 1 plus m1 m2. So we can write m2 minus m1, that is 3 upon 4, divided by 1 plus m1, that is 3 upon 4, into m2. Tan of minus pi by 4 is negative 1. So negative 1 times of 1 plus 3 upon 4 m2 is equal to m2 minus 3 upon 4, that is minus 1 minus 3 upon 4, m2 is equal to m2 minus 3 upon 4, and on simplifying we can write m2 plus 3 upon 4 m2 is equal to minus 1 plus 3 upon 4. So we can write 1 plus 3 upon 4 is 7 upon 4 times m2, which is equal to minus 4 plus 3, that is negative 1 upon 4. So we can write m2 is equal to minus 1 by 7. The slope of the second line, the new position line, is minus 1 by 7, and hence the equation of line in new position passing through the point minus 1 comma 1 and having the slope minus 1 by 7, we can write y minus y1 is equal to m times of x minus x1. So we can write y minus 1 is equal to minus 1 by 7 times of x minus of minus 1. That is 7 times of y minus 1 is equal to negative x, and this is negative 1. So we can write x plus 7y, and here minus 7 plus 1, that is minus 6, is equal to 0. So x plus 7y minus 6 is equal to 0, which is option A. So we can go with an option A.